In this video for section 12.1, we're going to introduce a new type of test called ANOVA. So first we're going to do a quick recap of what we've been doing. In chapter 9, we tested hypotheses that involved the mean of one population and comparing that mean to a number. We used one sample Z and one sample T, depending on whether our standard deviation was known or unknown. In chapter 10, we tested hypotheses that involved comparing two population means to each other. We used two sample T for independent samples and paired T if they were not independent. So now in chapter 12, we're going to test hypotheses that involve comparing three or more population means. So we have hypotheses involving the mean of one population, hypotheses involving comparing two population means, and now we're going to be comparing three or more. And we use a test called ANOVA for this, which stands for Analysis of Variance. And you can see we have the AN, O, and then the VA. So some examples of when we might use an ANOVA test is if we want to determine which of 5 major brands of golf balls has the greatest mean distance off the tee, or if we want to determine if there's a difference in the average miles per gallon performance of cars manufactured by 3 different automobile producers. So in both of those examples, we are testing a hypothesis that involves more than 2 population means. In our golf ball example, we have 5 because we're testing the 5 brands of golf balls. And in our EPA example, we have 3. So in this section, we are only going to be considering one factor or independent variable. And so we are going to be using what's called a one-way ANOVA. If you want to compare more than one independent variable, you would use a different test, and we're not going to get into that here. So each population or group that is compared is called a level. So in my golf ball example, I would have 5 levels. In my EPA example, I would have 3 levels. And we're going to compute a test statistic using Minitab that's called the F value. Our null and alternative hypotheses look like this. And so this is really important that you are getting these hypotheses correct. Our null hypothesis is that all of the means are equal. So mu1 equals mu2 equals mu3. However many levels I have, the mean for each is equal. My alternative hypothesis, at least one of the population means is different from the others. Now, what you need to be aware of here is that this is not the same thing as saying that mu1 is not equal to mu2 is not equal to mu3, etc. What this is saying is that at least one is different. So it could be that 2 of them are the same. So for example, mu1 could be equal to mu2, but it could be that mu3 is different. And if that was the case, I would reject the null hypothesis and have evidence for the alternative. So the alternative hypothesis is not that all of the means are different, it's that at least one of the means is different. Because that's the opposite of my null hypothesis, which is that they are all equal. So we're going to look at an example here. We have a sandwich company with 4 locations, and they want to know whether the dollar value for orders made by individual customers differ on average between the 4 locations. So maybe one of the locations people tend to order a lot more food, or maybe one people tend to order a lot less food. Either way, we want to know if there's a difference between the locations. And so we have these results, and we are using an alpha of 0.05 here. So when I look at these, I'm going to again start by writing my null and alternative hypotheses. So my null hypothesis is that mu1 is equal to mu2. Since I'm comparing 4 stores, I'm going to go up to mu4. And my null hypothesis is that all 4 are equal means. My alternative hypothesis, again, at least one of the population means is different from the others. So I'm just going to write that. So now we're going to do our test. The spreadsheet for this data is found in Blackboard if you want to follow along. You can find it there. I have it entered into Minitab here. You would download the Minitab worksheet and then open it in Minitab. So I'm going to go to Stat and go down to ANOVA and then click on One Way. And then I'm going to change this drop down to response data are in a separate column for each factor level, because each level, remember, that would be each individual or each store in this case, or restaurant, is in a separate column. So click on that, and then I have this box here for putting my responses. So in this box, I'm going to put each store that I want to compare. If I only wanted to compare some of the stores, I wouldn't have to select all of them. Like maybe I just want to compare stores 1, 2, and 3. I could just select those. What I don't want to do is select this customer column, because that's just the customer number, and that is not data that I'm going to want in my analysis. So select my 4 stores that I want to have, and then I'm going to click OK. And then it's going to give me my results here. I can move this down. And then what I'm looking for is I'm looking for this analysis of variance table. And in that table, in the far right columns, I see the F value and the P value. The F value, just like previously with the Z and T values, is something that you're going to need to put in the MyLab questions. So that's 1.03. And my p-value is what I use to determine whether I'm rejecting or failing to reject the null hypothesis. So I'm going to write these f values and p values down. So we have f value, 1.03, and the p-value of 0.393. And so again, we are comparing that to our alpha, which in this problem we said was 0.05. Is the p-value less than alpha? No, it is not less than alpha. So that means that I failed to reject the null hypothesis. And so what that means is that I do not have evidence that at least one of the population means is different from the others, or I do not have evidence that at least one of the stores has a different average spend amount.